So here are two multimeters. One is measuring the voltage and another one is measuring the current. Here I am testing a XL6019 Boost Module. I am giving it input voltage of 20 volt using the PD decoy module and measuring the output via the load. The load here is a very creative load because first of all I have two 5 ohms resistor in series which makes it 10 ohms, and then I measured a length of nichrome wire, very high resistive wire, length of nichrome wire, calculated the resistance of it, not calculated, I measured it via multimeter and pinched that point which makes it, and pinched that point which makes it exactly 25 ohms resistance. So at 25 volts and 25 ohm resistance, this load will draw 1 ampere of current. So let's measure it. So here the grounded pin is connected in this here, and the this part will be the VCC. This is the voltage and there will be the current. So you can see the current 1.2829, 1.2728. The voltage is not fluctuating, stable at 25.1 volt, 25.1 volt, and the current is 1.30 ampere, which is the exactly current which I need to charge my batteries. So this can easily deliver 1.30 ampere at 25.2 volt. And this IC is getting warm. I can definitely smell some kind of smoke. Oh, not getting warm, bro. It's completely fine. So that makes sense. So what I can do right now is that I can make a constant current circuit to upgrade this module and attach a CC feature to it. Okay, basically here you can see only one 10K potentiometer is there. This is to adjust the voltage. There are not any potential port for adjusting current. So basically I am right now using this buck module which has a voltage adjustment port and a current adjustment. Sorry, this one is the voltage adjustment port and this one the current adjustment port. So I need CC and CV both for charging lithium ion batteries. So basically I has my 4S pack which needs 16.8 volts, which is lower than 20 volts. So I have a 20 volt supply, need a 16.8 volt output. Hence I have used the buck or step down module. The step down module has the CCCV both, which makes it the perfect match to charge batteries. The main problem with the boost module is that there are not any boost module available in India with a current control or CC feature. Okay, that's the main problem. So to solve that problem, first of all I have rectified that if this module is powerful enough to deliver 1 ampere of current at 25.2 volts, which is definitely true for my case because the V out and the V in, the difference between V out and V in is not that great. The V in is 20 volts, V out is 25.2 volts. So it can definitely give 1 ampere of current at that particular V in and V out ratio. So now I only need a constant current circuit here, the efficient constant current circuit, to use it as a battery charging module for my 6S battery. Yeah, I will definitely build a 6S battery pack. I am not going to build a 7S. The main reason is that first of all it will need more than 27-28 volts to charge, which is a very hefty amount of voltage for this module also. And the second thing is that the second problem is that with 7S, the BMS board, the BMS board of a 7S battery pack is, I don't know why, a fucking expensive than 6S. 6S BMS available at 135 rupees and the 7S one is available at 700-800 rupees. The difference is just unimaginable. Whatever. uh, the main concern right now is some kind of op-amp circuit along with some kind of MOSFET or JFET to be able to make the constant current part of this boost module. And if I am able to do so, then I can definitely use it as a battery charging module. Here I was testing my XL6019 Boost module. To test that module, I needed to attach a load to it, and the load was 25 ohms because I wanted to make sure that it can deliver 1 ampere of current when the output voltage is 25.2 volts and the input voltage is 20 volts. Why I wanted to know that? Because I want to use it as a charger for my 6S battery pack, 6S battery pack, which needs 25.2 volts. Okay. So for that, when I need the 25 ohms resistor which can hold 25 multiplied by 25 divided by 25, ultimately saying 25 watts of power. So these simple resistors are 10 watts, not 25 watts. So this can't work. But uh, what I did is that I used first of all two 5 ohms power resistor in series to make 10 ohm. Then from this particular portion I have attached nichrome wire, okay, and I have measured the resistance of the nichrome wire and pinched that portion, that part which makes it exactly 25 ohms in total from 5 plus 5 10 plus 15 25, okay. Exactly that portion where the resistance got exactly equal to 25 ohms. So this is a very creative way of using nichrome wire as a variable load with almost 100 watts if I'm not wrong, because these kind of wires are very durable and they become hot when pushing a lot of wattage through it, but ultimately a lot of current through it, or wattage, whatever you want to say it. But the main concern regarding that, I mean, regarding this kind of uses of nichrome is that the wire gets too hot when I am testing the module. So I have to be cautious about any fire happening in this bed. That's not the main risky part of it. The main risky part of it is that it becomes red hot, okay. So by mistake, if I touch it when testing the module, my fingers definitely will be burned. And the main reason I had purchased 10 meters of nichrome wire is that I wanted to make a heating pad to do some kind of pain relief, to build some kind of pain relief product, but it really never took off because of some material issues, some issues with silicon. But currently I am using this nichrome wire as a variable load with almost 50, because today I have implemented 25 watts of load using nichrome, okay. So I really don't know how much wattage can I push through this single wire, so I am not sure about it, okay. First of all, this is the main thing. And uh, I was thinking that this nichrome wire is getting, I mean, this is a total waste of money because the main project I wanted to build with nichrome is not possible because of some other reason. But right now I'm thinking that I made a good deal buying nichrome wire, because it can be used as a variable load of, I think, up to 100 watts it can easily handle. So for any DC SMPS module, switch mode power supply module, you can reliably check their power using load as nichrome as a load, okay. Nichrome as a load. This 10-meter nichrome wire cost me 130 rupees from Maker Bazaar. So that's how I have used the nichrome wire to mimic a variable load. So basically there is pre-default 5 plus 5 10 ohms of resistance already in series. Okay. From this point, from this junction point, I can slide this alligator clip. At, oh, the alligator clip is already burned due to the huge amount of heat produced by the 2 ampere of current. Okay. So I can slide this alligator clip along with alongside of this nichrome wire, and this nichrome wire, this sliding of nichrome wire, I mean sliding of alligator clip over the nichrome wire will make different parts. I mean the increasing length of the wire, increasing resistance also, increase its resistance. So that will be helpful to mimic variable load. So I will lock my camera on the multimeter which shows the current. So we put the voltage meter also in this position. You can see the both at the same time. So when it's here, it's 1.27. So I'm basically sliding this pin, this metal pin across this nichrome wire. Okay, this visible nichrome wire. So 1.28 ampere, 1.34 ampere, 1.42 ampere, 1.78 ampere, 1.12, 1.93 ampere, and 2.04 ampere, 2.17 ampere, 2.16 ampere, 2.19 ampere, 2.19 ampere, 2.16 ampere. Short circuit, short circuit. So short circuit, not basically overcurrent protection. This is overcurrent protection. Okay, when overcurrent do happen, the supply drops to 5 volt. Okay, please ignore the negative sign of the multimeters because these just some polarity issues. And so when it's gives 1.14, 1 point, sorry, 2.12, 2.14, maximum it get was 2.19, 17, 17, 17, 19. Maximum it can go is maximum it goes 2.19 ampere at output terminals when the input is 20 volt and output is 25.2 volts. Okay, if I reduce the load or decrease its resistance below that, get the current much more than 2.19 ampere, then it will just say that if the over current protection will be turned on of this boost module. So currently it's 2.17, 2.171819, and then this is the overcurrent protection of the boost module. Okay, here 2.17, 2.19. See the overcurrent protection. But I don't know why when it reaches that overcurrent protection, the IC gets super hot. Although when I am drawing 2.2 ampere current at 25.1 volt, which makes it more than 50 watts of power, does not make the IC that hot. But when this setup goes at the overcurrent protection, making the output voltage at 5 volt, this IC gets super duper hot, almost untouchable, and almost not completely untouchable, makes it around 90 to 100 degrees Celsius. So that's a flaw because typically overcurrent protection feature completely shuts off the ICs. And yeah, that's the process of using a nichrome wire as a variable load, no matter how much wattage you want to push. So I think this will help you to uh, use nichrome as a variable load, and a very cost effective way of testing such SMPS modules. Now just imagine if this wire gets red hot, my blanket catches fire, I will be burnt alive. Okay.